really a stressful situation in that on Black Friday, right? And retail is a business of thin margins, and pricing is extremely important for you to actually succeed in retail, especially during events like Black Friday. Now, a pricing analyst who is in retail faces a number of challenges, right? He or she needs to make a decision in terms of what items he needs to increase the price for and what items he needs to decrease the price for, right? And he needs to do that while taking into account a lot of factors like the sales trend, competitor price, the amount of stock he has, and also things like whatever is the company's target margins and so on. So our agent really enables this pricing agent to effectively navigate events like Black Friday. Okay. So let me now move on to our project itself. So we started out very simple. We wanted certain key features in our system, right? We wanted our system to be easy to use in natural language because pricing analysts are not technical people. They're people with great domain expertise. We want our systems to be context aware and give consistent price recommendations at an item level. And we want our system to adhere to the guardrails and company policies. So with this requirements or problems, we've set about designing our system, right? So what you see is a user has a chat interface. He places a request, and there are guardrails to prevent unauthorized queries or price requests. And then the query understanding itself is done by an LLM, which fires 3 SQL queries basically to get competitor price, inventory, sales, and demand profile. Now, this is standard SQL queries, and the return, whatever is returned from the database, is taken in, and we create an aggregate prompt. And then this is fed into an LLM to do a price recommendation at an item level. Once the price recommendation is done, we have output guardrails to make sure that the price is adhering to any legal or company-specific policies. And then it goes down further to a piece of code which kind of checks whether the price change is significantly high or low. If it's high, then there's a human approval in the loop. If it's a low one, we automatically approve it and send it to a price DB. So this was our iteration 1. And essentially what we built was a workflow agent with RAG, right? This was the simplest thing which we could do. And the key evaluation metrics was, did we recall the company specific information like competitor price, inventory, sales appropriately? Did we adhere to the guardrails? And did the price recommendation make sense and was it consistent? Okay, so this is what we implemented in iteration 1. We then went on to say that we want a few more features for our system, right? So we wanted the competitor price information to be real time. We also wanted to do category level optimization, not an item level optimization. We wanted a repeatable and consistent price recommendation, irrespective of how many times we asked the LLM. And finally, we wanted an ability to do simulations for the pricing decisions. So this actually led to a slight change in our design, right? Because we wanted real-time competitor information, we had a scraper tool built in, and that would scrape the data and bring it into the LLM. And we had a semantic matching tool, which would semantically match competitors' SKU to our SKU. Because we were doing category level multi-item optimization, LLMs started hallucinating a lot. So we built an optimizer, which would be a tool which the LLM would call, and that actually improved the accuracy as well as consistency of the results. Now, because we wanted simulation and we wanted multi-turn conversation, we had episodic memory, and which would be kind of fed into the context of the LLM call. And at this point, we wanted certain evaluation metrics like the tool call accuracy, the price consistency, and so on. The next step, we got a little more ambitious in our design. We said the pricing agent should be looking for certain triggers in the market and then make automated decisions. Okay. So that meant a few more tools. We wanted an agent like a weather agent, we wanted macroeconomic agents, and so on. So it meant a lot more tools. And we wanted some autonomy in terms of action and planning, right? So this is where we started adding more tools. And to manage these more tools, we had an MCP protocol layer in between, right? The rest of the system remains more or less same between iteration 1 and 2. We also added an enterprise grade level observability and cost tracking system to ensure that we can manage the overall cost. So the evaluation metrics here was, of course, tool planning, accuracy, and we also had an LLM as a judge because there was a autonomy in terms of how the agent was performing. Now, building the tool itself.
Abhijit, quick time check. If you have a demo, you just have like 1 minute left.
Yes, I'm passing it on. So quick, yeah. In terms of building the tool, it was quite fun. So right now we'll have Issy talk about the demo, and I'll stop sharing my screen.
Thank you very much. Let me, hopefully, are the demo codes now with me and I find the right window. So thank you. I'm very excited to showcase iteration 1 in action. First of all, a bit of background information. We have 1,000 apparel items such as Adidas sneakers, Nike t-shirts, and we have data points such as current pricing and cost data, real-time inventory levels, sales performance metrics, and some competitive pricing information. And our goal for this iteration is revenue maximization. As a first, I would like to showcase you how our tool processes natural language. You see someone from the merchandising team. Do I have some more time?
Go for it.
Who is trying to find information for this particular item for the holiday season. And you see, this is the recommendation generated by our tool. And you see here an executive summary of the recommended action, what is the price change in absolute and percentage terms, and also what is the revenue impact per month if we do these changes. Also, the user is able to deep dive into the analysis which the tool provides of why this recommendation was provided, and also a bit of market analysis summary. Now, I would like to showcase also how our tool reacts or executes when...
Yes, sorry.
Yeah. Oh, you don't see it?
No, we can see the screen.
Okay, you can see it? Okay, I'll continue. So now what I'm going to showcase to you is how the tool takes certain price rules into account. For example, this particular one has a low stock level. And usually when an item has a low stock level, this is also connected with an increase in price in order to be able to sell the item. And this is what I'm going to expect from the tool. And this is what also the tool provides. This would be an increase of the price. And now I just want to showcase two final things. The one thing is make all items free. So this is one of the guardrails that we have introduced. And now the tool should not allow me to go further. And you see, even because we have hybrid guardrails, that it recognized that we are talking about reducing the price to 0. Back to our legit use cases, we provide a final dashboard, was inspired by Lovable, and thank you, Bhargava, for the idea, where you can see finally the recommended action, recommended price, and revenue impact for the items that you have selected, or the user. And again, once more, if one wants to deep dive into the analysis, one can do this here as well. And finally, if the items and prices are approved, they go into the DB. So thank you for watching, and I hope you enjoyed it.
Yay, that was amazing. Thank you, team. This was pretty cool. The next team, SREnity, Agentic Enterprise SRE Copilot. I love the name.
Everybody. Also, folks, if you have any questions about the projects and stuff, like you can drop it in the chat and the team will take a look at it if they can. Yeah.
Okay. Can everybody see my screen?
Yes, we can.
Yes, we can.
Thank you. Thank you for joining our demo. Stop me if there's any issues, but Our product is called SREnity. It's a wordplay on SRE. We hope to bring serenity to the chaotic world of SRE. This is our team. I request them to be on camera. I'm Anil. There's Ram, Dave, Mani couldn't join us today. There's Raj and Sterling. Dave and I will be presenting the demo today. So as always, starting with the problem, right? SRE is a large space. It basically sits between software engineering and operations. Software engineering team builds the products, operations team, they are deploying and managing the infrastructure. SRE team is focused on making sure the app that is running in production is working and working to the agreed SLA, right? So a lot of SRE involves a lot of activities. One of the ones that we'll be focusing on today is incident management, and specifically incident triage. If you are a product engineer, you already lived through this, you already know, but just level set for everybody, right? An incident is if you have a customer-facing production application, something like YouTube.com, Instagram, right? And if there's a defect that is impacting a particular feature, we call that an incident. If they are critical, something like, hey, I'm not able to go to youtube.com, it is classified as a critical, right? So in cases like that, we've all experienced outages. In cases like that, the operations team would typically bring in all the stakeholders. And if that is, again, critical and complete outage, there is higher stress to resolve that immediately, right? So typically the process would involve trying to look at the data in terms of how my APIs and apps are working, looking at logs, and trying to understand what is the root cause and try to resolve that, right? So the crux of the whole problem is there's real-time data available. You have to analyze that to get to the next steps, right? So which is a prime space for generative AI. So our project tries to explore what this could look like, right? So again, the focus is from incident reported to incident triage, right? So there are other areas too, but we're focused in accelerating the time from incident being reported to getting the next steps. That's the journey, right? So these are very specific to enterprises, the data is. So I've simulated with synthetic data. Sorry, go ahead. Yeah, so this is a dashboard of how an operations dashboard would look like. So this is showing, these are our APIs, these are our incidents, these are our alerts. Through my incident dashboard and I see a specific, there's a critical issue incident reported. So I'm clicking SREnity. So this is trying to look at and any past incidents that match this description and any recent changes in the from the changed request, right? And then trying to gather all the data and see what could be the problem and to identify the next steps and resolution steps, right? So this is running an LLM inference right now. And the result could look something like this, right? It was able to identify the specific S3 buckets that were causing the issue. It was able to correlate the supporting evidence and then immediate mitigation steps. It was also able to correlate what changed that we've done in production has recently caused this, right? So now instead of a team manually running this, they could take this data and then start from this and confirm this and then move forward. Right? So that's the crux of the application. We also have a backend implementation. Just to be clear, that demo was running on synthetic data. We have a back office backend implementation that is partially done. We'll share that, right? So going into the implementation details itself, we've went through the crawl, walk, run phase, iteration 1, 2, 3. In the main assumption to start with is the enterprise logs, traces, and metrics are available to be consumed via APIs. And we will implement tool calls based on that. And then we will add additional enterprise data to pull context needed for inference, right? So we'll come back to the details. I'll have Dave present the iteration 1 and 2, and then I'll come back to 3. So Dave, go ahead with iteration 1.
Yeah, sure. Hi, everyone. In iteration 1, we introduce a workflow agent integrated in the existing ops dashboard. The key capability is on-demand invocation, meaning engineers can trigger the agent during the live incident. It pulls the relevant logs, data, metrics, then traces on the incident metadatabase and uses the inference, LLM inference to identify the potential root cause and summarize what's going on. Moving into the iteration 2, Anil, maybe, yeah. We built on the foundation of iteration 1. Over here, we introduced the RAG, as Anil already said. We just implemented the vector database made from the historical incident postmortem reports. Now, when the incident is raised, the agent can contextualize the situation using both live data and similar past incident. This enhances its ability to provide accurate root cause analysis. Now, in the iteration 3, Anil, you can go ahead.
Yeah. So this is improving. I know we're at time. Can we take 1 extra minute? And I'll try
Yes,
it all
this is the
together.
6-minute timer, just to make sure
Okay.
you have enough
Oh,
time for the
okay.
demo. Yeah,
Well, I have 1.5 minutes. Let's try. So
including the demo.
iteration 3 is basically building on top of what we've built in iteration 1 and 2, right? So at this point, the evaluator prompt and the evaluation step has been perfected. We've built the pipeline for vectorization and building the vector database, and you're building other kinds of data. So relevant data would be change requests, meaning anything that was recently deployed, there's a change log, change record of that. We are providing context of that. There are usually run books when there's incidents happening. There's a script of how you execute incident management. This is called a run book, right? So you are building on top of the previous infrastructure. And at this point, this becomes a multi-agent implementation. There's an orchestrator agent that is going through reasoning and planning, and it leverages a React agent that can do agentic RAG and tool call to execute each step. And then the response is sent for an LLM evaluation. It goes through a feedback loop and presents the results back to the user, right? So tying it back to some of the optimizations and evaluation metrics. So guardrails, because this was not coming from users, there's no chat module, at least for this view. There aren't very major guardrails, but it is still rooted in software security and guardrails, right? So the optimizations are more focusing on an LLM that can execute well in inferences that are more on the code and development side. And by iteration 3, right? So leveraging memory, both working and episodic memory, and because there are multiple sections of the inference itself, maybe streaming output, right? So these are our optimizations and guardrails. So I think that's about it.
Awesome. Well within time. Amazing work.
Wait, also, folks, this was the demo that you built has a backend as well, and all of this you did in a week.
Yeah, so so there's a backend component, but that is not integrated in the demo. That was not complete. This is a repository. I'll drop the links to the repository and the working web app that is simulating the incident dashboard in the chat. That's live and anybody can be using that.
Yeah, and
Super
just to
cool.
chime in, a huge lift by Anil and Dave. They were the heroes that carried our team with some tireless effort.
Well, thank you. Thanks for
Awesome.
all the support, team.
Awesome. Really cool. Really cool. Moving on to the next team, team 3, proposal assistance. Wait. Okay. Folks named your team so long. Proposal assistance, including qualification, search, and feedback.
I'm sorry. Sorry for the very
clarify.
long name. We
That's okay.
pivoted. I'll share and get rolling. Thank you. All
Quick
right.
check. Do you guys have a demo or?
We do not have a demo. We
Okay,
only
perfect.
have
Perfect. Just wanted
our
to make sure.
plans. Yeah, no
Awesome.
problem. Appreciate it, Si. All right. Can everyone see my screen?
Yes, we can.
Perfect. Thank
Also,
you.
Tyler, quick heads up when you're explaining each iteration, make sure you zoom into them because this is a huge poster.
Yeah, no problem. We have slides. Appreciate
Okay.
it. Okay. Good morning, everyone. My name is Tyler Wallace. My co-presenter today is going to be Samantha Chill, and then also on my team was Ben Dizon, Whitney Doe, Elena Ruber, Bhavani Singh, and Arthi Subramanian. So our project is titled Agentic Solution for Qualification, Retrieval, Tailoring, and Scoring. As you pointed out, maybe a bit of a mouthful. So what does that mean? At large consulting firms, when we have new work that we want to go after, we need to identify, what previous work have we done that makes us a good match for this new work. And we call those our qualifications or our quals. And as you can imagine, there's a lot of context, a lot of team information that needs to be tracked there. So when you're writing these new responses, when you want to go after new work, it can take a lot of the team's time to find these previous qualifications. And in order to reduce that time, we wanted to see, could we design an AI-based solution where we could find these previous qualifications? And then once we've started to find them, can we take it farther than that? And can we start to tailor them to this new work and just help us to make sure we're responding in a quality way? And then can we also give ourselves an idea, how well do these previous quals really line us up for this new work, and get some input from the LLM for that. So the first iteration that we have, we just wanted to keep it real simple. This is very much, I think that was one of the main things I took away from this course is let's keep it simple, get it working, and then build on top of that. And so this first one is very much, get our previous qualification docs and embed them in the vector database, get all of that working. And then you have the user, and when they come in and they have the new work, or RFP, we call that a request for proposal, and they want to see what are our previous qualifications. They have a query, they have a chatbot interface, and they can submit that. That gets similarly embedded, and then you can search that vector database. Very basic RAG implementation, but that was just, step one, can we get this retrieval working? Can we make sure that we're retrieving the relevant qualifications? So kept iteration one very kind of basic there. And then iteration two, this is where we wanted to start getting a little more in depth. As you can imagine, as we chunk those first qualifications, there's a lot of context, like I said, that needs to be accounted for to make sure you're getting good previous qualifications. And so here we just added these steps where not only are these qualification docs going to be just embedded, we're also going to add an LLM summary where we ask it, can you provide a good overall context of the domain, the type of work that this is, and we'll include that in the chunking into the vector database. And this will help us provide that layer so that we can say, okay, we're going to get relevant quals, not only for the work, but for the domain, the type, maybe even the duration of the work. And then we're going to do a similar thing to the new RFP that comes into the new work. We're going to have the LLM summarize that. And then we additionally wanted to add a third item, which is when we get these more relevant quals from this sort of enhanced search, can you, now that you have this RFP context and requirements, can you take that and tailor these relevant qualifications, help us rewrite them and make sure they're a good fit for this new work? And that comes back to the LLM and is part of the query that the user is doing. Now, I'm going to pass it now to Samantha Chill to cover iteration 3, as she really did the work there.
Thanks, Tyler. Hey, everybody. So in iteration 3, we're adding a couple of new features. We wanted to add in a new algorithm that takes in additional insights, the probability of whether or not we would win this work based on the qualifications and some previous information. So just like we did in iterations 1 and 2, where we had our qualification docs building this vector database, which we're calling now our qualification database, we're also using historical win-loss documents in order to create a win-loss database. So this gives essentially our model now the ability to look past to look backwards, right, into the past and to see what type of work did we win and can we make some assumptions on that work. And what that's going to turn into is our predictive model. So based on a particular set of criterion, which would actually be able to be exposed to the user. So at some point they could say, you know what, I would like to rank qualification A more than B, etc. It is going to come up with a predictive model that we can now deploy on every new RFP. So not only are we getting what qualifications do we have, we're also getting what is the probability based on past experience that these quals and these set of circumstances, honestly, in this environment, would allow us to be able to win and at what percentage. That gives us also a bit of information, as Tyler alluded to in the beginning. This process can take a long time. It's a lot of work and effort. And so very quickly, we can use this almost as a screening tool. If we're getting really, really low probability of win efforts, then we might say this isn't something that we want to pursue, that we want to be able to, put a lot of time and energy into. So you can see in this slide, right, that we're getting a little bit complicated. We have two databases that are sort of sitting in the back end that we would ad hoc run. We have this predictive model. We have the user that's sort of interacting with the various components of the pipeline. And so on the next slide, what you're going to see, even though we didn't do a demo, we really started to think about how are we going to orchestrate this? And so this would be a multi-agentic AI workflow where we do have multiple agents sort of at the junior task level that are performing the specific tasks. And we have an orchestrator agent, which would be in charge of all of these individual tasks. And so you'll see from iteration 1 and 2, some of those are overlapping. We have an intake agent that we're now looking at tokenizing that RFI, RFP and creating some output structures, adding in that metadata. On the bottom part in the orange, we're sort of giving a little bit of the tech information for what's running underneath that. And as each of these agents are performing the processes, we'd imagine that the orchestrator would be sending information back to the user so they can see exactly where they are in the process. And the great thing about this is, again, you're not only going to get back within the report, right, of here are the qualifications, here is how it's ranked, but also here's a probability score that you could always go back and adjust if it's new parameters. So this hopefully gives you an overview of exactly sort of where we were thinking of going, and with this multi-agentic agent, also how we would implement new additional features if somebody wanted to add something else to this workflow so that we can make sure that we're being efficient with our time.
Samantha, can I take a quick look at your evals and all of that table as well? The one that you showed initially, your poster?
Yes.
Perfect. I think quite a lot of vision that's gone into building this. So super, super impressive. Thanks, you both. Awesome. Thank you so much for presenting.
Thank you.
Yep, thanks.
Okay, next team is InvestorIQ.
Hey, morning all. Let me share my screen in just a second. Oh, okay. Yeah, please confirm you can see it.
Not yet, Nagesh.
Not yet.
I'm sorry, it's asking for getting access. 1 minute. Let join back in just a minute. Sorry.
Sure.
Yeah, go ahead.
Folks asking for GitHub links or links to the poster, it will be all sent out to you as an email. So you don't have to worry about it. You will get all the team's resources attached to the demo day Notion link itself, right? And the meeting recording also will be sent to you over email. You don't have to scrape through all this chat. So I'm just telling you that you can be rest assured and kind of pay all your attention to the presentations.
Yeah, and if you want to connect with any of the folks in the teams, the LinkedIns are also available in the Notion page we shared.
Okay. Is my slide visible?
Yes, it's visible now.
Yeah. Sorry for delay. Firstly. Okay, before I talk about the problem statement, I just want to thank Aish, Kiriti, and the entire learning partners and my lovely team for all the, communications, conversations, so on and so forth in the last 3 weeks or so. While we certainly talk about the problem statement for this, why we are talking what we're talking, I also want to lay a quick overview of the roadmap and the evolution of the agents that we're planning to have, and some quick sneak peek into what are the evals, some guardrails, what we're thinking. But at a high level, we don't have a demo. Sorry for that. We'll move on for this morning. Okay, what we're trying to solve here is more targeted towards the board directors or CXO group, who often have to face the public and analysts every quarter to relay the company performance and take the questions and answers, right? So for that reason, there's a lot of groundwork that goes into, because I've been in the space for almost one and a half to 2 decades almost. So there's a lot of prep that goes within the company itself, and let alone the drama around investor calls. Okay, with that challenge, and you might be wondering, aren't there any solutions today? Yes, there are, and no, also. Yes, because the last 2 decades have seen a lot of improvements in the Oracle EPM or maybe any EPM space, but the problems that analysts deal with still remain as of today. And after deliberating a lot of approaches, be it traditional automations or GenAI automations and agentic automations, I've narrowed down to this approach, wherein we can automate most part of what analyst does today in the run up to the earnings calls. And why should we do this? What's the benefit of doing this? It could definitely save anywhere between 50 to 60K per enterprise, and it could expedite from 2 to 3 weeks to the same of days. And most importantly, the risk involved in misrepresenting the facts or not able to answer the questions of analysts is a huge cost to company. Then the very next day itself, we see the dip in the stock price and market cap down, right? So with all these constraints, challenges, and benefits that we can foresee, is what we have tried to do. Okay, so let's see what the high-level 10,000-foot roadmap that we're targeting. First is analyst copilot. The analysts, as we mentioned earlier, they do a lot of groundwork, so we can start heavy lifting most of that effort into some mix of hybrid AI effort, I would say, by identifying what are the variances or deltas, and they try to reconcile day in, day out, and generate some preliminary commentary that they can leverage from AI. And once that's knocked out, we can think of, okay, now is the time to prep for analyst questions and answers. How have we failed in the past, and how can we do better this time? Is something this can help. We'll see some wireframes, how this might shape into. But ultimately, the goal is to have a portal or insights generator ready for CXO group, so that we have enough recommendations and they can be very well prepared to face the analysts. Okay, with that roadmap, I mean, it's still evolving, but I just want to throw some light into what I'm thinking. For each of these iterations, I want to plan in I didn't share flowcharts, I agree, but just want to throw some tools that we have planned to use to develop these tools, these iterations. Maybe I'll spend in the next slide a little more time to walk okay, what we envision the final architecture is going to look like. We have a slew of agents doing excuse me. Yeah, doing multiple things around upstream monitoring and the downstream monitoring, downstream analysis, and a central nervous system, I would say, for the knowledge graph at the center. And again, how do we let the users, which is board of directors and analysts, interact with it? And how can we present the insights in a crisp fashion? And again, the most important for any CX, CEO, or CFO is how can they simulate the forecast, let's say 1 year from now, or 5 years from now, 10 years from now, right? So that engine, there are some engines which can do that, but they're not infallible at this point. And there's several challenges I'm still grappling with to finalize this. Most notably, the granularity of these agents, because each of them have to be very specialized, and there should not be overlapping that's involved, right? And the integrity of knowledge graph has to be maintained so that the multiple sources do not tarnish that. Yeah, obviously, it goes without saying the communication protocol has to be very top-notch. How do we deal with the upstream real-time feeds versus downstream siloed analysis? That's still being evaluated. Okay, even from a core component, technical components perspective also, there are still some open gray items that I'm deliberating. For example, the orchestrator, it cannot be just a simple task router. It has to dynamically adapt to the iterative nature that it might have to deal with, right? Okay, moving on. Okay, a quick sneak peek into Excel-driven wireframes, how they might look like eventually, right? The very first iteration might just talk about, okay, how are we faring in different regions and what's standing out, and what are the reasons for the variances, or why is it doing what, right? And if they want to drill down details, they all have separate tabs around what are the sources we dealt with, what are the slides that we can present eventually, and some settings to let them tune again and again, right? And as an analyst, I should be able to rerun sync data with the latest and greatest feeds, and also create slides from scratch, right? So that's one very primitive level one of agent, not agent, sorry, the solution. And moving to this is where things get interesting, because to really anticipate the questions and answers from analysts, because every earnings call, there will be a cloud ball for every company, right? So for that reason, they'll have to be very well prepared with what are the predicted questions and what could be the answers. And again, we can't just take it face value of what AI generates. It has to be internally reviewed and approved by the group. That's why we have introduced the approval mechanism or approval workflow, right? Which will be tightly integrated within this agent. And last but not the least is where I'm really excited to see how it actually shapes up eventually, is a comprehensive view of everything put together. What does the street think about us? How are we faring for this quarter? And what's the key takeaways from the analysis that we've done in prefer analyst call, right? And where are the key risks that we can be better prepared to present, right? And I think that's about it. Okay, I don't have time, but it is what we've been thinking about. What evaluations we can consider system-wide, specific to agents, upstream, downstream, then HITL, so on and so forth. And guardrails were very interesting. It requires an hour to explain in detail, because financial ones can give a data level and so on and so forth. Operational, we all understand. Human in the loop, again, same. Ethical, DA, somebody mentioned DA in the beginning. Model data also, right? I think that's a wrap for this morning, but I hope to present in a month or two in the H&A sessions, how it shaped.
I think I really love this because of so much deep thought into the user experience itself. So just the entire user journey and stuff like that. So pretty cool. Really loved it. And I will skip to the next one, but thank you so much.
Sure, thank you.
Next team is HireQ, Agentic mock interview and coaching system.
Yes. Hope my screen is visible.
Yes, I can see it.
Yeah, okay. So hello, everyone. Thank you for joining us today. So we are a team of two. I'm Kalpana and I have Sai along with me. So today we are excited to present our project, HireQ, an agentic mock interview system. So the problem statement here is basically in every enterprise today, interview readiness is critical, be it a client-facing role or internal mobility or hiring decisions. So the challenge here is every client has unique expectations. And yet we prepare our employees using manual mock interviews where people hardly, scrape the web to find the most common interview questions. So these methods are static, disconnected from the actual project context, and often give limited insights into actual readiness. So many times managers spend a lot of hours manually to match the job profiles to roles or to curate the role specific questions and to collect the feedback and so on. So 90% of the effort is repetitive, hard to scale and unstructured, and employees will walk into interviews, using unprepared and uncertain. Right? So let me picture this. Consider you are a project manager with a critical client interview coming up. Right? So you have 2 days time to pick up someone from the bench to face these client interviews. So you'll pull up few resumes, do some analysis, and based on that, but you're not sure, who are actually prepared. So probably you might go with some instincts or based on the existing data or do some mock sessions, but all these are generic. No insights, no context, just guesswork in most of the scenarios. Now shift the perspective. If you are an employee, you have done a lot of certifications and projects, but when you actually sit for a client interview, probably most of the questions might seem unfamiliar in many scenarios because those questions will be very specific to a tool or a domain or process that client actually cares about. So but in this case, particular employee will walk out thinking, I could have done better if I know what they were looking for, right? So this is the reality we want to set out for a change. And to address this challenge, we have built a multi-agent, intelligent mock interview system, which will solve the problem of facing client interviews, right? So this is our application. So this is the landing page of our application. So probably this will give some static text to you. So as a user, I need to click the start assessment button. So when I come here, basically because my data is already there in the database, so it is just greeting me, hello Kalpana, I'm so-and-so, what would you like to do today? So there is a classifier, intent classifier agent behind the scenes, so which will pick up, which will route the request to specific workflows based on what I'm choosing here. So let me just show you. If I pick up to take a mock interview, I'll just click on this mock interview because my details are already there. I hope you can hear the sound. There is a voice as well, but based on the details that are there in the system, it will just show me the job profiles or job opportunities that I have in my organization. So my data is saved as DevOps engineer, with DevOps skills internally. So based on that, it is just showing me what are the internal job hirings going on for. So let me just select, I want to apply for senior DevOps engineer. I'll just click on this select. Now it will show me what are the skills required for that particular job role, what is the experience required, and it will ask me to upload the resume. So I'll just click on this upload resume and select my resume where I have all the DevOps skills and everything. Now resume fit agent will do the analysis and it will compare my resume with the job role that I'm applying for, whether my resume is fit to apply for that particular job role or not. So we have put a score gatekeeper here, like if score is greater than equal to 70, the resume evaluation will be passed. If it is less than 70, then it will give a feedback or suggestions, probably saying improve your resume or learn these skills, right? So here my score is showing as 95 and it's giving me some feedback that you have this proficiency in this skill, which is expected for that profile. Now it will start asking me questions. So what I'll do to save the time, I'll just pick up the answers from Gemini, but sorry for that. So so employee or user, just have to pick up, type the answers accordingly. So let me just put up some answer here and press enter. So it will analyze the answer. And based on how much clarity I have given, for every answer, it will provide me the individual feedback. Like it is saying good basic explanation, but could be improved by providing specific examples, right? Then it will move forward to the second question. And so just for demonstration purpose, we have restricted these questions to 3, but basically it is adaptive and will pick up the questions based on the flow or the clarity that you are providing in your answers. So this is the second answer I have given, but I think this is also not complete. So it is saying the explanation is too brief. So then the third question is, what is the purpose of AWS? So I will here say it as I don't know, right? So then, so this is the feedback that it gives. You have improved, you're in the top 17% of candidates, right? So now,
just 5 minutes. So
yeah, I
wrap
will take, yeah, I'll just hand it over to Sai. Sai, you can. Yes.
Yeah. So guys, thank you, Kalpana. I mean, so we also have an analytics agent, but I think we're just running out of time. But yeah, I'll just quickly go through the iterations. So we have built a system that basically listens smartly, coaches personally, or reports intelligently. So basically, we began by building an intelligent, cost-efficient base through model tiering initially, because we have used a model called as GPT-4o Mini, which is a very small model just for an intent classification. So where it's just forced into a JSON mode, where just giving with minimal latency and output. So because we want to do the intent scoping, because we want to be pretty much into the unit economics per interview, what is the cost per user per interview session. So that's where we brought in this intent scoping, where we are using the powerful models only for doing the complex tasks. And we have also put some eval metrics for iteration 1 with respect to F1 score, where we probably judging the precision, accuracy, and F1 parameters in order to make sure that a response is well guarded. And also we have done some analysis on cost per sessions, when we are doing the analysis. And probably for the iteration 2, if you can see there, we have tackled, because primarily if you just query the LLM, it's always outdated questions, similar questions. It does not have any user system persisted. That is where we have brought in the second iteration, where there is a session persistence. Along with that, we have also added a rack system where we have taken in some bunch of questions coming in from the client interviews. It could be the previously asked questions, where it is pretty much our USP for our organization. So that is where we have bundled up into the vector database. And pretty important improvisations that we brought here is, because there is so much of latency and LLM calls involved, we have brought in batch retrieval, where when Kalpana was demoing the 3 questions, it was not asking one after the other. The 3 questions will be brought before, so that we are saving on the latency. And for the vector database also, we were having the hybrid search, so that our metadata is being pulled accordingly to our tags that we have given, instead of going through the entire embeddings. And embeddings also, we were using OpenAI embeddings and pre-embedded into the database, so that it will not do it in the runtime. And the important guardrails that we have brought here is the retrieval confidence threshold. I'll just wrap it up, just 20 seconds.
Yeah,
Retrieval confidence threshold, where we are just acting that we have just put an LLM as a judge to see whether the question that is asked is relevant to that role. And final iteration is all about bringing the analysis into the picture, where we have built in that LangChain MCP model, where we are using SQL connector. Actually, so I think there we have used a complex model called as GPT-4, because it's about getting your query and then putting back to your SQL and then getting the response back. So there quickly we have done smart catching, and we have basically done, we made sure one important point, that DB names should be in plain English. Any cryptic things we have put there, it's been failing. So that's basically the eval and the metrics that we have put there. But it's purely on MCP, where the classifier, the moment it judges it as a analytics thing, like, what are the scores, who are the top contenders for this role, or who are the how is this person behaving based on its previous interactions, all the details it can actually get from the database by using this particular phenomena. So I think on the right hand side, we have actually put in the latency metrics, optimizations, what are the different things. We have put guardrails like read-only SQL, so that user don't delete the data. We made sure that only read-only data is being retrieved using that LLM, using that LangChain MCP connector, and not the other queries, right? And the last thing is, we have also put the SQL generation accuracy, so that we have put in some queries and seen how it's actually responding, so that it's not actually because sometimes it doesn't understand the table names, the row names and stuff. So that's why we have also done the analysis of doing the SQL generation, right? So yeah, that's it. It's not just about an interview assistant. We have built a platform that's really built for impact and scale, and we are using this in our organizations. Thank you.
Awesome. That was
awesome.
Such a wonderful demo. I think you already have customers as well. Like, I can see folks in this chat saying they're going to be using what you built, and so much attention to detail, like all the caching and just making sure that you're doing well on the latency. So pretty cool. I think this was one of those demos where there's a lot of implementation insights that you've gotten as well. You've spent that time. Thanks, folks. I'll move to the next
we should really thank Ash, you and Kiriti. It's an awesome job, and I think we will really take this knowledge for life. It's awesome. Thank you.
Awesome. Thank you.
Thank
so
you. And
much.
it is also a nice mic drop moment at the end, where you said you're already using this. So that's a nice thing to consider as well.
Thank you. Yeah.
Okay, our next team 6, Agentic Troubleshooting and Repair Coordination System for Field Equipment. I'm super excited for this one because it's a new space.
Right. Can you hear me and see my screen?
Yes, we can.
Okay. All right. So this is a project for agentic troubleshooting and repair coordination system for field equipment. I'm Gargi Baiba, and I'm joined by my team, Hari, Vishwakant, Komal, Ramya, and Prakar. The use case we have chosen, so field equipment is a very broad space. So the use case we have chosen is for urgent failures in the utility industries with the scope of water purifier failures. So the reason is that water purifier failures, the downtime could have very negative effects, both on the environment and also public safety and health. So this is a very important problem, we thought. And then the goal is that how AI agents can analyze the error messages when these systems are down, help retrieve the solutions to the technicians, and also manage approvals and order parts. So this is the use case with the goal to cut down this downtime with keeping in mind the impact it has on the environment and public safety, and also reducing the human reliance along the way. I will pass on to Vishwakant to show a demo first before we go into the details.
Thank you, Gary. So I hope I'm sharing my screen. It's visible.
Yes.
Yes.
Yep. Directly getting onto the demo so that we can say what we have built. So it's a customer support portal or a technician support portal. And then I'll just give Vishwa. The product which I'm trying to solve is RO purifier. I'm saying. So it's at the back end, it is connected to a lang flow through an API and then trying to get the results. It's going to show what is the problem, what is the kind of a category of the problem you're trying to solve. It also provides probable root causes and corrective actions. So you can see that it is the initial description, what is the category, it belongs to pump or a motor circuit, what are the probable causes. It gives the corrective action, provides a replacement part summary if defective. It also provides the link on where to purchase. And after that, let's say if I place an order for start pump, it just it goes to the back end and then creates an order to place an order. Okay, and then to see whether it's placed an order or not, I will show as an evidence that I have a backend. So I'll just refresh it. You see, it placed an order for booster pump at 8 p.m., which is Central Time. And then we also have a contextual memory here. So place another order for the part mentioned earlier. I'm not giving any part here right now. Yep. So if I just go refresh my screen right now, it placed another order here. So what we have tried to solve here is at this point of a time, we have taken only one of the manuals to figure out the diagnosis as well as finding what are the probable root causes and then trying to find a resolution and then ensuring that for the replacements parts, you get the real-time data from Amazon, Walmart, and then try to place an order and then using the memory to ensure that it understands the system. I'll just stop it here. There are some lessons learned. First, we will go through the system design by Gargi, and then we can talk about the lessons learned, how we have implemented it. Over to you, Gargi.
All right. So as we thought about the design, the first step we had in mind was, let's just help the technician to find out what's the root cause of the problem. Okay, something's gone wrong. How can we help the technician? So we're prompting, simply we would like to prompt the LLM first with the subject matter expert curated what are the various fault categories and we enforce the topic guarding to ensure the outputs will stay within these fault categories. So there were several optimizations on the prompting that were considered, and finally we chose the route of meta prompting. One of the important guardrails is the user can be frustrated when something goes wrong, so an offensive language filter might be important, and also making sure that we controlled the fault mapping category, the category that we have in it, and not to go outside the fault categories that were listed. The evaluation metric that would be important here would be the word match, because we clearly say these are the metrics and please provide the guidance within this scope. Now that the user is equipped with, okay, what went wrong, we would like to further equip this technician with, how do I fix the problem? And this is where in the iteration 2, we went ahead and thought, well, we'll use the user manual. So we were able to get some water purifier manuals that were available that we used to provide this information to the LLM. And important things to consider here are the embeddings and also the data parsing for the optimization. Important guardrail here is for threshold on the relevance and also the length of the response. We want actionable troubleshooting steps from a trusted source, and we want to make sure it's an approved documentation. And I think I should have mentioned the business constraints, but I'll go to that last. So last iteration, what we thought, all right, the user now has what's the root cause, how to go about the next troubleshooting steps. Now, let's help the technician to actually what do we call with thought fulfillment also. So in this last step here, so in here, once the user has this, the technician has this information about how to solve, what are the parts that needs to be, what are the parts that are needed to fix or whatever. So now we used an agent to orchestrate few actions for the technician. One, first to go to the tool inventory and see if there's already available parts within the inventory, and now come back with this information. And if it is not available, then we do the next step of having a business constraint that came into place here, is that there are management approved thresholds for each part and also vendor information. So this is included at this level. And now with this information and the part required, the agent is now going onto the web and searching for links to buy the parts. Now that the part is, the links are available, we want to include the human in the loop. We don't want to take the human completely. We want a human to actually look at this before and give an approval, just yes or no. We have eliminated the management approval costs, looking for things, but we still want to give the final decision to go to the human to make that decision. And now the parts are ordered. The important guardrail here is prompt injection, not to bypass these threshold limits that the business constraint has, and also to stay within the parts of vendors and also the purchasing threshold limits. We also have to check that the links provided are not fake, and there's no fake links. That's a guardrail to be set here in place. The eval metric that will be very important here is the tool invocation time. Like you have seen, we are invoking different databases, the total time and total execution time. We want to make sure it's not something very high or more than what they would do it if they just did it by themselves, I guess. So, or it should be
Gargi, 30 seconds left.
Yeah. And then we have the last factor, which is the success rate. We want to make sure that the orders are placed successfully. So this is the evaluation metric. Also that was considered, and there are several optimizations for scaling and governance. So I will pass on to Vishwa for some lessons learned.
I'll just take 30 seconds just to put the lessons learned. I'll just finish it off in 30 seconds. Yeah, so often in enterprise, we have a high degree of determinism, which needs to be solved, right? So we went with a low autonomy and high control. So we went with the workflow agents, and we did not consider the agent components of workflow. And then we use GPT-0 mini, O-mini, because it is providing a better latency and a lower cost. And finally, one of the good lessons we learned is, unless you get your problem on the paper and if you're able to visualize it, do not go for coding, and try to be simple in doing the design, else you might have to be an expert in dealing with chaos. Thank you.
Such a wonderful closing statement.
Awesome. Amazing last words. Yeah.
Yeah, really cool, really cool. I really love how you took it from lower autonomy to higher autonomy, which is exactly the flywheel that kind of allows you to understand what's happening in the process. Really amazing work, folks. Moving to the next one, Team 7, GMAT Prep Test Coach.
Hi, everybody. I'll just wait a moment for my colleague to put our slide on the screen. Thank you so much. So we're excited to present ScoreCraft AI, which is an agentic GMAT prep coach. This capstone was designed for busy professionals who are aiming to maximize their GMAT success. And our fantastic team was comprised of myself, Sareen Gandhi, Shrey Datta, and Trupti Veer. And Shrey and I will be presenting today. So as we were thinking about the problem that we were facing, the issue is that working professionals really struggle to find time for GMAT prep. You may know that this is the admissions test to get into many business schools, and learners often wind up studying the wrong topics. They potentially waste hours of time, and they may end up having to retake this expensive exam, which can be costly and stressful. And currently, many people spend a lot of money on expensive courses and costly test prep materials, when really what they need is an intelligent coach that will understand their specific weak spots and give them exactly what they need, no more, no less. So our solution is ScoreCraft AI, which is an agentic learning system which adapts intelligently to the learner's profile, to their behavior, and even to their emotions to give them targeted study plans and questions and feedback and even support during the process. So we built this in 3 evolving iterations, and Shrey will give you some more details about each in a moment. But overall, iteration 1 is a rule-based coach, which takes a user profile and recommends study content and questions accordingly. Then iteration 2 adds AI-powered personalization using RAG to adapt content based on the learner's past mistakes and weak areas, and really uses true GMAT content for doing so. And then finally, iteration 3 introduces a multi-agent empathetic coach. So this layer understands the student's emotions like stress or frustration, motivation, and even triggers human assistance when needed. So within that, there's a debate agent that will allow them to argue their answers with an AI peer, making the prep even more engaging. And throughout this, we've integrated SAGE and DICE data sets, which personalize the motivation and detect emotion in real time. Ultimately, this isn't just test prep. It's about building confidence, reducing burnout, and boosting performance with smart agent-driven learning. So I'm going to hand over to Shrey, who will walk you through some of the technical aspects of what we've done.
Thank you so much, Claudia, for setting up the stage. I'll go ahead and show about the iterations in detail. So our iteration 1, as Claudia mentioned, is a rule-based diagnostic coach, which is essentially a workflow agent. It takes in the input from users' sign-up flow, as in during the sign-up flow, we are asking questions like, what is your target GMAT score? How comfortable are you with GMAT quant right now, and so on. Using all those variables, a study plan is generated for the user. And then when they go on with the study plan, there are learning content generated and practice questions generated for that study plan. And then on the basis of answers given by the users, there's a feedback loop to the study plan, and the questions coming forward are revised on the basis of their responses. The problem with this approach is that since we are using a workflow agent, we do not have a lot of control over the learning content which will be generated and the practice questions which will be generated. So to address this, in the second iteration, we have implemented a RAG enhanced adaptive coach, where we have introduced a RAG vector database, where we have embedded all the GMAT quant material in a RAG vector database. And using that vector database, all of these learning content is generated and practice questions are generated. And even the explanations for these questions are generated using that RAG database. And that the way that RAG database is designed is it is having one vector per question, so that we have all learning content and answers and question and its hints in together in one vector. And also in iteration 2, we have introduced a concept of semantic profile or semantic memory of the user to retain the semantic memory of the user about their difficulty level, which they would prefer, and at which stage are they in their learning journey. Along with that, we have also introduced a SAGE-driven gamification approach. In iteration 2, SAGE is a student reward preference dataset, which allows us to understand which are the rewards like points, badges, or narratives, which are suited best to keep a particular user engaged. In the iteration 3, we have implemented a multi-agent empathetic coach, wherein we have a master orchestrator, which is having a diagnostic coach to understand the student, an emotions coach to understand the emotion of the student, a content synthesizer, a debate agent. All of these agents are in communication with each other through the master orchestrator. Along with that, we have also introduced a DAISY video dataset, which is basically allows us to understand the emotional state of the user from their video cues. And based on all of these cues, we are also triggering for a human in the loop if it is required. If student is not progressing well, we are triggering for a human in the loop. And coming on to the evaluations, we have a target set. Sorry, I'll just take 30 seconds more. We have a target set for each iteration. Like for iteration 1, we are targeting a greater than 80% diagnostic quiz completion rate. For iteration 2, we are targeting 20% score improvement on weak topics and 90% answer relevance. And for iteration 3, we are targeting plus 15 points in topic mastery gain. And for each iteration, we have defined guardrails. Like in iteration 2, we have a guardrail which is required to cite the source in answers so that we don't have LLM hallucinating. And in the context synthesizer, we are making sure that the content which is being generated for the user is being generated offline so that we can balance the latency. That's all from my side. Thank you so much for this opportunity. Thank you so much, Ash and Kirti, for teaching these concepts. This is really helpful.
Awesome. I really love this. I wish I had something like this when I studied, because it really feels like you care for the students so much. It's kind of embedded into each of your iteration, and can see a bunch of comments saying that they would have loved to have this as well. So thanks, folks. I really love the emotion part of it, where you're so connected with the student itself. It's just not a learning app. It's so much more than that. Thank you, Claudia, and Shrey as well, and the rest of the team. Moving to the next one, Team 8, AI-powered venture capital personalized pitch generator. This looks interesting.
Hey, yes. So let me share real quick. Okay, so I'm Claire and worked with Pallav. We were a 2-person team, a no-code team as well. So I've noticed in the comments a few people like, wow, like these are so technical. I'm so impressed. Like it is also accessible. Of course, like great course, even if you're not like an engineer by trade or anything. So we'll show you what we've done. So Pallav came up with a great name since we submitted this. So this is Pitch Perfect, our AI-powered venture capital personalized pitch generator. So the so what we were looking at, So founders, when they're pitching, they're often spending a lot of time tailoring their pitch decks based on the investor they're looking at. It's not always clear what investors are looking for, especially if you're just getting into the space. The space itself is fairly opaque. There's not a lot of like super accessible data, like it's not, filed, all of that. Anyway, so there's a lot of research going on to it, storytelling going into it. So the thought is that AI agents can retrieve investor activity, match portfolio themes with company strengths. Oops, sorry, just lost it. And then automatically generate personalized pitch materials aligned with each investor's theses or prospectus. So I'll be going over iteration 1 and 2. Pallav will take it from there. But some of the business constraints that we were looking at, I'm hoping this is, viewable. So data privacy interests are going to be a really huge one for this. People don't want their business ideas getting out there, etc., before other people. Checkers and hallucination guardrails. You definitely don't want anything in your pitch that you can't back up, that you're going to have to, it isn't part of your pitch. So those are a few of the considerations that were going into this. So iteration 1, we kept really straightforward, just a very simple prompt-based workflow to generate a tailor-based, a text-based pitch. So no documents involved or anything like that. But so user prompt, so they'll just be able to put in their business idea, whether, talk to text or typing it out. The LLM will come back with a list of relevant VCs from what it's got there, and then a user prompt will be able to choose that VC, and that will help them generate that tailored pitch based on that. So very, very basic 101 there. Iteration 2, we wanted to kind of update the data that it's pulling from more. So RAG comes into play here. Workflow agent comes into play here as well. So the hope, again, it's kind of an opaque thing, but we're going to assume that we have access to CSVs of known VCs, their fund information, prospectuses, all of that to be able to pull from here. So here we would want a user to be able to upload a document, say they already have a pitch going, already ready, upload that. Workflow agent can tap into a vector database that we have of VCs, fund prospectus, etc. Again, we'll be able to list relevant VCs with much more robust details than before, verifiable details. And then again, a user prompt, you can choose a VC and then help tailor the pitch from there. So those are our iterations so far. And Pallav, if you want to take it from here, that would be awesome.
Cool. So basically, as per the plan or the reference sheet that we had, we went just by it, and it kind of a great help. So we started pinning down what are the limitations that we had from iteration 1 and iteration 2, and then we wanted to slowly evolve. And the first thing we all aligned is in the iteration 3 is, hey, when we wanted to go for the Agentic AI, the main reason is because we wanted to understand we wanted to navigate the ambiguity part and then do market research analysis and then learn from it. So these are the things that we've had in mind. And then we also thought about one thing very clear from the start is no multi-agent is required here. So that's again based on our reference sheet, it helped us, hey, what exactly we want, which one should get introduced here. So now walking you through on the iteration 3. So here the new introduction is that instead of workflow agent, we thought, let's involve the Agentic AI. So once the let's say the co-founder or the founder who uploads their business ideas, then the Agentic AI will kick in from here. So two things will happen in parallel. One, we wanted to introduce MCP also. The main reason is because to have a seamless connections with the APIs, let's say, for example, PitchBook and Crunchbase APIs, because these have all the venture capitalist fund. And in the long term, we just don't want to focus on VCs, but across multiple segmentations within the investors channel. So we wanted to retrieve those details through their the APIs they have. And also in terms of the RAG, we wanted to keep on updating and then don't want to retrieve every single time from these APIs. So these are the basically we wanted to go ahead and do this. And in terms of memory context, we also wanted to maybe Claire, could you slightly scroll below? Yeah. So the scroll below, please. Yeah, basically we wanted to have episodic memory as well as semantic memory. No worries, also. So episodic memory and semantic memory and as well as the procedural memory, basically the last one being like doing a personalized tone for the procedural for each of the investors. Maybe zoom out, please.
Cool. Yeah. So basically, once that is done, then we will have a tailored pitch, and then human in the loop is also introduced here. The main reason is because we wanted to have a guardrail, and since we are talking about a lot of the investors' data, confidential data of our own companies, we wanted to have a human in the loop review, and then based on that, there will be a final tailored pitch works on. So we will also have a plan to generate the slides using Google Slides or Slide Pick, etc. So that will also come into picture. Now I will just 5 seconds or 30 seconds. What I also wanted to touch base is a quick idea. Yes. So maybe in the definitely for in the AI session, chai session, we will come up with the backend as well. But this is a quick UI that we are able to develop with the internal repositories or data that we have planned. And we thought we will be on time. That was our plan, but somehow it's kept. But yeah, nonetheless, this is what we will do, and we wanted to have it like a very, very concise one, because a lot of these days there are too much of data points happening, but our pitch desk will focus on very concise points. So that's it from us, and thanks for this opportunity. And it was a really great cohort, and we learned from the cohort as well as from the instructors. So thanks for it. Yeah.
Thanks, folks. I want to start using this. It looks super cool. I feel like a lot of people don't really tailor their pitches to investors well, and it just makes you think that there's so much information online that you can get in order to, be pitch perfect, I guess. Thanks, folks. This was pretty cool.
Yeah, I love the
Next,
name, and the ideal scenario I assume is something like you build this and every project in this cohort uses this to pitch VCs,
Exactly.
and that would be amazing.
yeah, that would be
Yes.
so cool. I feel like, founders should take quite some time to build their product, and building a pitch is like a huge time consuming thing. So if something could automate that well enough. Pretty cool. Okay, next one is Visa Application Agent.
Can you guys see my screen?
Yes.
Yes, we can see.
Can you guys see my screen? Sorry.
Yeah, we can see your screen.
Okay. Sorry, guys. Okay, team. So we did slightly change our name to PSA, the Public Service Agent. We're going to dive right into it. I want everyone for a few seconds to please close your eyes. In all seriousness, Ash and Kirti, you too, close your eyes. Okay. Imagine your mom. Imagine her trying to visit you in the US if you live there. Imagine her trying to Google her way through and go to multiple websites that have non-intuitive sounding names like CEAC or US Travel Docs. Imagine her trying to work through the process feeling frustrated. Imagine her making your favorite childhood dish and then stress eating it. Imagine her essentially deciding to spend her retirement money on some Visa agent because she was just intimidated and frustrated with the whole process. If you still have your eyes closed, you can open them. This is what happens millions of times every year. Every year. And so to understand the magnitude of this problem, just the US B1, B2 visas, which are the tourist visas, there are roughly 6 million visa applications that were filed last year. This is actually a low from 8.5 million it used to be pre-COVID. Across all these applications, you've got problems like there is information fragmentation, that you've got to go through multiple websites. There is a lot of preparation burden. There is no clear information around what you even need before you even start the process. And of course, there are language barriers. If people, because of these problems, spend even 90 minutes more than they should on this, that's roughly 8.8 million hours being spent every year filling out these stupid visas. To put that in context, that amounts to about 1,000 years being spent every year. To put that into context, that is basically 10 people with 100-year lifespans doing their entire life filling out visa applications and then dying every year. 10 million or so is being spent on third-party agencies that are helping folks try to apply for these visas, an industry which we intend to disintermediate. Why Agentic AI? Because we are able to work through this fragmented information landscape. We are able to personalize the guidance. We are able to very easily overcome the language barriers. And we are able to, my team will talk about this, also deploy leveraging some tools and MCP servers on WhatsApp, which is a tool that is used globally very frequently outside of the US for communication purposes. Before I hand it to my teammates, here is a quick view of what something like this could look like. You can come here. It's you will. Our iteration 1 was focused on just for Indian applications. We've got various tabs within our UI. It's got quick links, official resources, and things that you can do for help. If we go to form sections, you will see that it will tell you what are the form sections you will need with some estimated time frame, what are the required fields, and then India-specific guidance, which our system prompt is helping sort of sort through. So for instance, if I go to travel information, here is what I need India specific. There are documents that you would need, which people don't really have in one place very easily, along with, not just valid passport, what is the India specific requirement? Again, our iteration 1 was focused on India. Digital photograph should be this requirement, India specific, no tilak or bindi, etc. And then you can have some common mistakes. So unfortunately, almost 80% of the forms have errors. There are name mismatches with passports. There are incorrect date format is one of the most common because of the DDMMYY thing. So calling that out up front for the users, prevention is better than cure. We have another tab around resources, which will give you everything. Of course, with one of the things being that this is not an official assistant. And then we have a step-by-step guide, which is going to allow us to be able to kind of traverse through the entire form. And if I can say, tell me about DS-160. It is able to or start a step-by-step guide, and it says, go here, make sure you do this. We were able to put a voice chat mode, which speaks both
Hello,
English
voice
and
assistant is
Hindi.
working.
And so
Namaste,
that is a
voice
demo.
assistant
I'm
काम
going to
कर
pass
रहा
it.
है.
Actually, I'll continue screen sharing. I'll pass it though to Helen to walk us through some of the iterations. Helen, over to you.
Yeah, thank you so much for doing the demo. And so here I'll walk us through some of the iterations. I think we can go to the next slide. Yeah, so over here, we're going to talk through the first iteration, which will just represent our core workflow. So over here in our first iteration, what we want to do is to allow our applicant or our user to be able to query our agent, and our LLM will be trained on the various government web sources that we kind of touched upon to be able to answer whatever questions that the user might have regarding the visa application process. And in addition to that, our agent will also be able to take the user on a more step-by-step, like piecemeal journey on the visa application process if they choose to start from the beginning. So overall, it's going to be just this core capabilities offered in our first iteration. Yep. And then, yeah, as we go through our second iteration, what we're going to do is we're going to incorporate a couple of new features that are going to be able to optimize the efficiency and the accuracy of our agent. So number one, we're going to have a prompt catching system to improve the latency of our responses and also lower some API call costs. We're also going to introduce a RAG vector database to store information specific to the visa application form itself, so that the agent can easily retrieve information on that form, as it is not as regularly updated as some of the other announcements or other processes regarding the visa application process. We're also going to have a web monitoring system, which will be flagged whenever the various government websites that we are basing this off of have changes. And so in that way, we can update our agent to notify whenever there are new announcements, such as changes in deadlines, requirements for specific nationalities, and any other details that need to be continuously tracked for the user to successfully submit their application. And then lastly, we're going to have sorry, if you don't mind going back to iteration 2, we also have this conflict handler system that will be able to sort of like incorporate different sources of data and offer and just notify the user, or like try to reconcile whenever there are conflicting directions that are published on different government websites. And so, yeah, those are the concepts that make up iteration 2. And then lastly, for iteration 3, what we're really going to do is expand our agents' capabilities even further. Yeah, so over here, what we're really trying to do for 30 seconds is we're really trying to expand and try to make our agent more universal with WhatsApp integration and voice capabilities. And I'm going to pass it to Brooke, who will talk about evals really quickly.
I'll spit through this. Look, we knew firsthand the different pain points of these applications because our team actually went through this process with our parents. And those issues and pain points guided the way that we thought about evaluations. The first one right there, I think, is a really cool one that we're including in our prompting, which is if there's a general rule that tells you B1, B2 visa requires statements, but specifically for India, it requires statements for the last 6 months. So our tool includes in our evals a system that would allow us to detect if the input is correct or not. Same with the cross-conflict detection that Helen just guided us through. In that case, our tool would warn the user that 2 sources of information had slightly conflicting information. So we're giving them that extra layer of transparency so that they themselves can also check it out. And there's a human in the loop added into that. And lastly, faithfulness, seeing how well our RAG system actually retrieves the information from the different documents that we're including.
Sorry, the time is up.
Thank you. If I have 10 seconds, one, do you mind going to the last page, Saurabh? There. So in a nutshell, what we truly want with this is going beyond B1, B2 visas. There's an addressable market of $2 to $5 million on top of the $10 million that already being spent on visas. Lastly, we can go beyond visas by helping other government services. And the most important is that we will be impacting more than 6 million users by decreasing their burden, and most of all, by making these services available anytime in their own language.
Thanks, folks. This was really cool. I think we should take your entire pitch and feed it into Pitch Perfect so that they train their system. It was very well done. I feel like you've gone through the pain yourself. We can see all the passion that you folks bring, and super exciting. I really love how you scaled it to other things as well, because this problem as a whole might not be a product, but then when you kind of scale it to other things, it just makes it feel so complete. Like I can just go to your website and kind of use it for any government related stuff, because we know that it's not going to get better anytime soon. So there's so much scope for this. Thank you so much.
That's our mission is to make government more accessible to people and to disintermediate a whole host of cottage industries that have no right to exist.
That is strong. Thank you, Saurabh. Next team is CISO, Virtual Chief Information Security Officer.
Hi, everyone. Can you guys hear me okay?
Yes, we can.
Okay. My colleague will be sharing his screen. All right. So my name is Pranita, and I'm joined by my wonderful team, Marius, Amit, Arun, Sharon, and Ginger. We are very excited to actually introduce our project, which is vCISO, Virtual Chief Information Security Officer, protecting small businesses from cyber attacks, one incident at a time. We're going to walk you through the business problem, why this problem is very important in today's world, and then we're going to showcase the demo, like the vision for our problem statement, and then we're going to touch base upon the design iteration process. The core problem that we are trying to address here is most of the small or medium-sized businesses, they lack a cybersecurity plan and the literacy to act fast when any incident occurs, in their POS systems or in any platforms that they own. This makes them extremely vulnerable to breaches, regulatory fines, and operational chaos. This is not at all rare. I mean, unfortunately, that's the reality for millions of small, medium-sized businesses today. Our solution is going to equip the small businesses with the step-by-step cybersecurity guidance, just like a real CISO would do, with the much-needed education, planning, and practice, everything automated. So we're going to showcase our vision for this problem through the demo. And before the demo, just a quick point to note, we have actually went and studied the psychology of small, medium businesses to inform our design iteration process, or how should we think about the product offerings. Think about like a basic product offering that could be our iteration 1, and then going from there to cater to wide range of audience or the businesses out there. And also this study and the research also helped us to simplify the UI and the tone of what we are considering to showcase in our product itself. Amit, you can go ahead and play.
CISO, your virtual cybersecurity officer. 95% of cyber attacks target small businesses. Average cost, $4.45 million. 60% never recover. Most small businesses are sitting ducks with dollar signs painted on their backs.
Meet your virtual cybersecurity officer, the cybersecurity expert you can't afford to hire but can't afford not to have. AI-powered protection that learns, teaches, and evolves with your business. Level 1. Learn and build cybersecurity basics for beginners. Learn fundamentals. Build your first incident response plan. Perfect for businesses whose current security strategy is hope for the best.
Level 2. Fortify advanced gap analysis using NIST frameworks. AI identifies vulnerabilities and provides expert fixes, because knowing your weaknesses is half the battle.
Level 3. Protect, maximum protection. Multi-agent training, real-time threat simulation, continuous improvement. Your team becomes a cybersecurity fortress.
3 levels, 1 goal. Maximum protection. Don't be tomorrow's headline. Be today's success story. Start your cybersecurity journey now.
Thank you, Amit. Our vCISO has been designed with 3-step smart iterative process. So I'm going to touch base on the iteration 1, which is learn and build a plan. Now, our team's guiding principle at this point was meet the user where they are and then take it from there. So the goal here is to help the SMB owners understand and build their basic IR plans, especially those with no cybersecurity background at all. So our prompt engine, meta prompting engine, is going to classify the queries into one of 2 types. Either it's an education request to help the users to understand the cybersecurity concepts in a better way, or it's part of IR building process by gathering the structured responses. Now we can think about, like, do we want to incorporate an LLM call here? Again, taking the problem first approach, we thought we're going to start with query classification rules and then take it from there. That's what went into our V1. And the LLM call is mainly used to generate the coherent responses and the tailored IR plans, and also providing the education content, making it easier for any business owner to read. Now, coming to the metrics, again, we have looked at the ground truth evaluation, basically very much customized for our problem statement. Some of the metrics that we have considered here are plan completeness. Are all the necessary IR sections included to ensure our AI has built a usable plan or not? Here we have looked into things like template matcher or rule checker to kind of create these metrics. The another thing is scenario matching accuracy, right? How well is the response matching with the user situation? So we're gonna have these test queries with the ground truth to ensure the response is matching with the user situation. The another thing that we have also actively considered but not like looked into the implementation part is the feedback from the test users. Probably we can use this to guide the iteration process or the further iterations, right? One of the learning that we have had at the iteration 1 is the way we're going to evaluate iteration 1 is going to extensively guide us through iteration 2 or 3 or 4, the further enhancements that you're going to do to your product. At this point, I'm going to hand it over to Amit, and he's going to walk you through the further design of our solution.
Thank you, Pranita. So on the iteration 2, you saw the offering, which is Fortify, right? As you can imagine, most standards evolve in silos. The problem statement in any of the standard reinforcement is to ensure that there is semantic understanding across different standards and ability to act based on the different recommendations that sometimes seem like counterintuitive to each other. The idea really for this particular capability is to create a semantic understanding across general different dimensions of the documentation, and then coming up with a recommendation that makes most sense for the users to act on, right? So in this situation, what you're seeing is the user is going to ask for what are the gaps from the policy that they implemented in version 1. And then it is going to give you the mapping with respect to gaps itself, right? So the key things that we are building here is the gap analysis report. Like I said, it's a semantic understanding of the standard versus what the users have implemented so far. And also the accuracy through citing named sources. This is not figment of imagination. This is standards bodies, and you have to comply by those. So creating a more closed loop feedback there, right? In terms of evaluation, we are going to use, especially in terms of the first step is actually looking at what is the most relevant embedding, because this is a cybersecurity domain. We felt I'm going to just take 30 seconds to go to the last iteration and go from there. So this we had to look at the MLEP standards and look at E5 a large V2 as the core embedding that would be used for understanding cybersecurity language, and then cross correlating between them. Optimizations definitely is corrective RAG. From a guardrail standpoint, the feedback, the citation reinforcement that I talked about gives you a more level of accuracy. And then lastly, there is no room for hallucination in this situation because the users are already concerned about this space, and they need a recommendation that is more relevant to what they are looking at, right? So things like knowledge mapping and knowledge F1 scores are going to be relatively more better evaluation matrices, right? Now the level 3 of this, as in this is acting on behalf of the people to basically make them more secure, right? What we are thinking about is obviously we have to bring in more data as compared to what you saw in the last iteration in terms of real-time threats that are happening, as well as the current ecosystem of what is the situation around what's happening in their enterprise, but also bring in a multi-agent view with a agent manager or a key orchestrator that is guiding which agent is coming in when, right? It's not a free for all multi-agents playing and playing together, but it's a manager delegator pattern that would be used there. The key again from a evaluation matrices standpoint is again a human in the loop for escalations, because this is key company data that might be getting compromised. We looked at the cost and latency parameters. When you are in an active ransomware attempt, the latency is going to be a key determining factor in terms of this situation to be adoptable. So we will weigh heavily on the latency reduction situations, and the multi-agent situation with memory caching and React as the core framework is going to help us solve for that latency problem. So in the interest of time, this is what we have at hand. This is a key need of the market itself, and it was a pleasure to be a part of the program and iterate through these steps. The GitHub link is there in the presentation itself, and we can share what we have built so far.
Thank you, folks. I think there's such a deep knowledge of the space, and it comes through as you do the presentation. So really cool. I feel like these are the kind of vertical solutions that people need to focus on, because the model is pretty much just a tool for you when you're building it. So super cool. Loved the demo as well. Congrats. And I will move to the next one, which is AI Grid Flow.
Okay, let me figure out how to share my screen here.
We won't start your timer just yet, Chad.
Thank you. Wow, I can't make it share.
You might need to drop off. Okay, you're able to share. Awesome.
Yay.
Okay. No, it stopped sharing. Damn it. Okay. So what we're looking at here, I'm assuming you can see my screen. Let's check. Verify that.
Not yet.
Oh my God.
At least I'm not able to see that.
Yeah, I can't see it as well. I think it's gone into the share mode, but it's just a black screen.
I can
Maybe you
share.
wanna-
Yeah, Artem, can you share? I can try.
Yes, we can see this one.
Okay. Yeah, first slide, please. Okay, so our problem here is we have field workers out in the field maintaining substation and the various grid assets that are in the substation. Think transformers, breakers, reclosers, that sort of stuff. And these crews, when they're out there maintaining it, usually it's planned work, so it's not so bad, but a lot of cases, they're emergencies. It needs to be restored quickly, and it needs to be completed quickly. So what we're trying to do here is generate concise, accurate, and very importantly, safe procedures for the field workers so they can do better work more quickly and more safely.
Just a quick check, Artem. I just see the screen super zoomed. I don't know if it's just me.
No, I can see it fine.
Okay.
I'm seeing the substation
Okay.
maintenance part.
Sounds good. Then go for it.
Okay, so that's our problem statement, and it's absolutely a real issue because we do have crews out there working on stuff, and it can be very, very difficult. Artem, can you go to the next slide, please? Okay, so we have.
The screen. Go ahead, sorry.
Okay, so we have we looked at our 3 iterations here, and the first one is most reasonable. We're going to be doing procedure generation from Bragg. There's lots of existing maintenance documentation on how to work with all the stuff. And we have the work order information, which contains like the trouble code and any recommended stuff that came from the back office. The most important guardrail here is safety, because since you're working with high voltage, it's very easy to, well, you could actually, field workers can die because they can be electrocuted. And obviously, second, the procedures need to be accurate. So we replace the right stuff correctly. And we have a rather tricky constraint here. This infrastructure is classified as critical assets. So it cannot be shared. Well, the sharing rules are very restricted. And so typically you can't share like outside of the company. And definitely if you're using any cloud stuff, there's limitations on where the data can reside. So our iteration 2, we want to add the ability to supplement with past work orders, potentially adjust the procedures using weather. And this is actually very important, the next one here. Like the crew goes out there and they basically said the transformer is running hot. When the crew gets out there, they see that there's actual damage to the transformer. And so they found something different than they were told in the first place. So they need to be able to update the procedures based on what they found. So that's one part. And then next, we want them to be able to query procedures for more information because there's always more. Like maybe you need to know how old this transformer is. Maybe you need to know what other procedures should be involved. And obviously the guardrail, we want to make sure that we're providing relevant and appropriate information to the field workers, not stuff they don't need. And iteration 3 is very much pie in the sky. We want to include diagrams and illustrations how to do this. A lot of this is actually in the procedures, so we would source it from there, but we need to make sure we find it. And that's about it. Artem, please show what we've accomplished.
Thanks, Chad. Okay, so this dashboard, as you can see, I hope you can see in the screen, is what we quickly build up for our iteration number 1. So that's a dashboard for the field worker who's performing the work in the field on a particular assets and stuff. So here we have just a few sort of like quick numbers for how many work orders are critical and pending, how many work orders are already assigned, what is the weather on the site. Every user is getting authenticated and should go through authentication process. Here there is a bell for notifications which will be received by the user if based on some IoT data there are some alerts happening, and you can just go through them and mark them as read if required. Then this part contains the list of work orders, which can be represented or visible in the map as well, because every work order has a geolocation associated to this work order. And when a particular work order is open, there is a detailed work order page which contains the procedures generated by LLM. So it will print the list of assets on that side. Then it will display all the hazard information and the safety procedures, which Chad mentioned, because this is a very important part. So all of the safety procedures can be done and marked as completed. And then same for the work procedures. So this is actually detailed list generated by LLM based on the RAG system we have in the backend. So this interaction between this front end and the backend is happening through API. There is no like a chat messaging system. All of the information and the request to the model itself will be handled by the backend itself. So there is no like front end interaction. And when something happens, like in the use case which Chad explained, when the team comes on site, they see something different from what has been assigned or mentioned in the work order. Something happened and they cannot really perform the work which is assigned to this team. They can open this simple snippet of chat and then mention what is actually missing or what new condition actually happened and stuff. This request will be sent back to the LLM to recreate the procedures based on the new conditions and the information provided, and this will come back as a response So now it's just a plain response. We haven't merged this with the work order procedures, but in iteration 2, we have been planning to improve that using MCP and all of that stuff, because we want to do in iteration 2 some past history for the work order, check if the same or similar work has been done before in different sites and stuff like this, so that that information is presented to the field worker to make a decision which process to go. That's all. Thanks.
Right on time. Thank you, folks. I really love how neat the interface is. It's the part about not having a chat system around it and making it so easy for folks to act on it is super cool. And I love your logo as well. I don't know if you had it even before you entered the project, but pretty cool work.
Yeah, that's all AI generated. All the pictures and the PDF files for our rack system, everything is generated by AI.
Yeah,
no real
we
data,
had
it's all
AI make it all up. Thank you very
Awesome.
much.
Yeah, thanks, guys.
Last but one team, Act on It, which is an insight curator and growth partner.
Hi, everyone. So Ed will be sharing the screen. So, hey, our project is Act on It. So we have a product video. So Ed, can you start the video?
Your journey is starting to be the best athlete, dad, partner, or even the next CEO. You don't just work hard, you read hard. In between business meetings, basketball games, and date night, you're reading, learning from history and the legends that came before you. You're trying to grow into mastery, but you haven't put your actions into practice, and most of what you read quickly gets forgotten. Until now. With Act on Lit, your growth is just a click away. Easily recall and interact with all of your past highlights in the chat tool. And leverage Act on Lit to build action plans. Growth isn't about merely knowing, it's building habits. Don't just read, act on Lit.
Okay, so the objective of our project is to help users to turn their readings to action. So the use cases, the professionals and the lifelong learners usually spend hours collecting valuable information from the books, but due to their busy schedule, they struggle to implement their learnings into action in real time. So as a result, a lot of valuable insights that they gain are forgotten, and it's a missed opportunity. So we designed an app that helps user with their saved contents. Here, the saved contents, I mean, the book highlights, for example, when you read a book in Kindle, Instapaper, and other apps, you mark a specific sections that you find interesting as highlights. So Act on Lit helps user turn their highlights into actionable plans, and it helps to foster personal and professional development. So app can streamline the process of revisiting what the user have read and enabling them to transform it to the meaningful behavior. So here are some facts, and as it says, like we hardly remembers 10% of what we read. So we going on to the iteration. The iteration 1 is a simple workflow where the user sends the query with the user highlights that whatever they had read in the book to the LLM, and the LLM gives the summarized results. And in the iteration 2, we went on to build a rack system. So what if the lifelong learners have multiple book highlights? So we created the embeddings of those, and we sent to RAG orchestrator. And when the user queries, the relevant chunks are received to the LLM. And we also integrated the session memory, and the action plan is created. So it can be like, I have read an Atomic Habits book, like, can you summarize the plan for growth mindset? So it can give you the plan. The LLM can generate the plan for it. In the iteration 3, where we incorporated tools like email, calendar, we also plan to incorporate the X and then the Spotify to React agent. So it is a multi conversation between the agent and the user. So when the user asks for a plan, and LLM gives the initial plan with the set of actions, and the user can approve or reject and ask for alternatives. And what happens here is the React agents will have autonomous power where it takes all the user feedback and then it generates, it blocks their calendar for the specific actions, and then it sends the email notification. And in further, we wanted to integrate the Spotify application or X application through this iteration, and it can also recommend relevant Spotify podcast at X, so that the user can develop personal and professional growth. So Ed will give you a demo on this application.
Thank you, Vishnu. So before we talk about demo, I just want to quickly highlight this table that we also worked on. For each iterations, we balance on costs and latency and figure out what's the right optimization for each iteration. So we want to make sure that it's safe for our users, and also in each iteration is designed for meeting our requirements. So let's quickly, this is a quick setup just to show you how we put together the demo. First is we actually need to load up the vector database. So I'm actually using one example, single user, and this is actually my own database of highlights that I've collected over the years, and then I use a agentic work on end-to-end, and then I hook up onto a web UI. So let me just show you the demo. So in this is a recorded demo, but it's a live demo. So I just asked the agent, I want to learn about growth mindsets, and so it go off to the agent and retrieve based on my previous books I read on the highlights. Those are the highlights I've made, and what would be the action plan if I want to keep learning about these skills. And then I would say, okay, I really want to see how I can learn, take a learning plan, and they actually give me the timetable for learning. But if I want to see, okay, I want to really start learning, and put a event on my calendar, so the agent will understand that, and it will actually go off and do a tool call to my Google Calendar and put in a calendar. But it first needs to confirm that what actual dates and time I want. So that's how I put in, and because the agent knows to have that before actually go off to the calendar. This is a slight glitch here. Actually, it sends the output onto the screen. But so all I did is I just say, okay, make sure you put it on the calendar. And that's got into the calendar. So that's the end of the demo. I think we got it before time.
Yes, you have 10 seconds to spare. I love the demo, and one point quickly to add was I like that for the act on it, you have like a literal action of putting things into Google Calendar. So love that addition to the product.
Yeah, that's one of the key things that we talk about, that as the the behavioral change.
Yeah. And this is one of those apps where you're like, I didn't know I needed this, but then it's so cool that it exists. So pretty cool, folks. It was really nice. I hope you productionize it soon and we can start using it.
Thank you.
Thank you.
Awesome. The last project is agent to personalized recommendations for restaurant, SMB, payment management. I'll let folks take over.
Awesome. Thanks, Aishwarya. I'll be presenting my screen. Okay, so we changed the name a little bit. We are called
Thank you.
POS Pal. We're basically a restaurant POS recommendation system. So let's talk about who's in our team to begin with. We have Suprina, Hemant, and I. Let's then focus on what is our problem use case. So if we talk about just US alone, we have 750,000 restaurants in just US, and this was an estimate from 2023. So we expect that this number would have grown. All of these restaurants require a POS, but they not only just require a POS, they actually require a bunch of other things other than just, cooking delicious food. So things like taxation help or order management or getting more capital to increase the size of their restaurant or integrating with tools like DoorDash or Swiggy or managing tips for their wait staff and many, many other features. But it's quite hard to understand which POS systems actually offer these and which offer these at the most competitive rates that as a restaurant owner, I can start using. So that's on the restaurant side of the things, but there's like a reverse side of the problem, which is, let's say I'm a POS company, I sell indirectly via independent sales organizations to a bunch of restaurants, and I find it hard to actually explain all the things that I offer with the most competitive prices that I offer it for. So how do we solve it? So what we've done here is we've built a personalized agentic system that provides POS recommendations based on user requirements. And if we extend this a little bit further, we can say that the same recommendations can expand to all SMBs, not just restaurant owners, because all of them have very similar needs and requirements. So just to give you a sense of how big that problem is, just in US alone, we have 33 million SMBs. And we could eventually expand the system not only to be just a recommendation system, but it could use those recommendations and be truly agentic and use MCP servers where it could apply for the right POS tools and then eventually integrate via agents seamlessly. So that's a little bit of background. I'll jump into the demo a little bit. So we built this using Langflow. This is basically a completely no-code solution and built by non-engineers. So I want you to be aware of that. Let's say I'm a restaurant owner in New York City and I need a POS recommendation that provides help with billing, tips, and taxation. So let's send this and see what it returns. Okay, so it looks like it's accessing a business profile agent and it's saying, okay, you've given me 3 things to think about, but there are some other things as well. Do you want to think about these as well? So looks like there's invoicing, payroll, reservation, some of the other features as well. Let's say I'm interested in website and mobile app. Okay. So I do that. That's a very long wait time. Okay, so looks like I'm being asked another question, which is like, how many covers will you have per day? And what is the average order value per cover? Cover is usually, how many people that you would be serving and what is the order value per person. So let's say I'll be serving 50 people per day. And let's say total order value per person for each of those 50 people is going to be $100 because I'm a very fancy, expensive restaurant. So it's taking all of that and building up a recommendation. It will take a little bit of time. So I'll switch back to Canva just to save some time and talk about how did we think of these iterations, and we'll come back to the recommendation once it's ready. So iteration 1 was very, very simple. The idea was to take a chat or voice input. that goes through an agentic system. This agent has access to a web search tool as well as message history. And then this agent gives a chat output, which is basically the POS recommendation system. In iteration 2, we went a little bit further where we actually introduced RAG. So imagine that you have a bunch of POS contracts because you're a restaurant owner and all of these companies have been pitching you their awesome features and their lowest rates. But it's hard to understand what these are. So you take all of these POS contracts and you upload them in a vector DB. From there on, we go into a agentic system where you have a chat voice input that goes into a master agent. This master agent has access to a bunch of tools. We begin with a business profile builder agent. So this agent makes sure that it has all the information required to actually come up with a recommendation. All of your contracts are in this vector DB. From there on, you have also access to a tool called Calculator. From there on, you also have a recommendation agent which says, okay, I have calculated out of all of the agents, what are the agents that support your use case? But then out of those, what is the best POS agent that you should go ahead with? So not only I have like a list of agents, but I'm providing you one specific recommendation as well. And from all of that, we go to the chat output. If we zoom in a little bit into the master agent is serving as an orchestrator. It's also serving as an LLM judge for all of the agents that it's accessing. And then finally, it's serving as a response builder. Now, that was iteration 2. Let's go to iteration 3. In iteration 3, the new changes that we think of doing is basically having everything from iteration 2, but giving this master agent access to external data sources like Reddit and YouTube. And the idea here is, okay, I have all of these contracts, but I also want to understand what are people talking about, these POS systems in all of these feedback forums, such that I'm not going in blind. Like I have all of these contracts, but I also am using my community knowledge to come up with a POS tool that works for me. So I'll skip back in the interest of time for the demo. By this time, if you see, my agent has given me a POS recommendation table. It shows me for each of these POS, what are the features that matched, what are some of the additional features, one-time cost, monthly fixed cost, and monthly variable cost. It also tells me what is the best match and why is that the best match. And then lastly, it tells me what are the features that are not supported. So it looks like all the features that I asked for were supported by all of the POS that are recommended in this recommendation table. That's all I had. Thank you.
Thank you, Farheen. This was pretty cool. So much attention to detail. Do you have background in this space? Because it just looked like you knew quite a bit.
I'm just a PM faking through life.
It was not evident at all. Awesome, folks. That's the end of all our presentations. And our cohort members who are here, we'd like to stick around for a picture. So please turn on your cameras. Those of you who've joined externally, we would request you not to turn on your cameras because this is a cohort picture. But let's take a picture, folks, before we drop off.
I love the fact that demo gods just like stuck to this call. Not one single team had an issue with demo, and it never happens in real life. I don't know how. It was amazing.
Right, looks like we have 5 screens. I will.
Yeah, the hint is to keep smiling until Aishwarya clicks all those file photos. So you don't know which one you're going to be. Aishwarya, you're on mute.
Oh, wow. Okay. Okay, folks. I will say 3, 2, 1 about 5 times. 3, 2, 1. Okay, next group. 3, 2, 1. All right. 3, 2, 1. Last one. Okay. 3, 2, 1. Awesome. That was the end. It was, man, we're so impressed. We have to kind of go back and kind of check our scorecards again. And you're giving us a hard time to make a decision, I guess. And we also have folks coming in the evening. So congratulations on all the effort. I could really see you folks think so deeply about the problem. So that gives us a lot of joy that you went so deep into the problem, really understood what it takes to build something. So thank you, folks. This has been pretty good. I'm kind of out of words for the first time, but we are super, super, super excited.
So, thank you for the framework. And I think the poster design also helped, kind of think through, procedurally, right, and evolve. So thank you for all the support. And I kind of feel bad, like, hopefully this is not the last time we will all meet, but everybody please stay active on Slack and stay in touch. Thank you. This was amazing.
Yeah, I think as folks mentioned in the call, it feels really like a proud moment just to sit and listen to all of these projects. And yeah, I think the worst part comes after this, where you have to pick one, and that's the part I hate the most. But it was amazing to listen to everything, and we have a bunch of amazing things happening in the evening session as well. So excited for that.
Yeah, thanks to Ashwin and Kiriti as well for developing such a great content with structured approach and delivering these projects. Without your assignments and content, it would not be possible.
Yay. Also, just a quick announcement, folks. This evening, I will send out a Slack message requesting you to share any resources that you want us to share publicly. So this will go along with the recording, right? So whatever you want us to share, we want to kind of leave it up to you, whatever you want to make available. So just keep a lookout. I mean, keep an eye out for that announcement. But otherwise, that's pretty much the last thing we need from you, and you're free to go. And your certificates should also come out today, so you should be able to share them wherever you want. It should be available. I think today is the last day according to the Maven thing, so maybe at the end of the day. All right, have a nice day. And folks who joined in now, try to make the time in the evening as well. We have more presentations coming in. Until then, bye-bye. Saurabh, really cute daughter. Bye.
Thank you, everyone.
Thank you
Bye.
so much.
Bye. Thank you.
Thank
Bye.
you. Bye.